Today, we are settling in for an immersive, long-form explainer on a topic that literally holds our entire modern world together. And since we're taking advantage of this perfect widescreen aspect ratio for a YouTube long video today, we're going to really take our time with this deep dive to look closely at the techniques, the tools, and the sheer scale of the welding profession. It's a fascinating blend of physics and engineering. So get comfortable and let's jump right in.
90%. Think about the scope of that number for a second. 90% of all manufactured products require some form of welding. Whether you're driving a car, sitting in an office building, or just using everyday household appliances, practically everything around you has been touched by a welder. It's like the invisible glue of human engineering, quietly supporting the entire infrastructure of our daily lives.
To really wrap our heads around this complex industrial process, we're going to break this explainer down into 5 clear steps. First, the engine of manufacturing. Second, the 4 core welding methods. Third, the 5 essential joints. Fourth, professional setup and safety. And finally, we'll look at real-world applications.
All right, let's kick things off with Section 1, the engine of manufacturing.
If you walk onto any massive, sprawling factory floor like this one, it instantly makes sense why this industry is tied to a staggering 78% of the gross domestic products. I mean, sweeping across these giant assembly lines, you quickly realize that entire sectors, we're talking heavy construction, automotive, aerospace, they all rely completely on this highly skilled workforce just to function. If we didn't have them fusing these essential pieces together, the gears of the global economy would literally grind to a halt. But what exactly is it? Let's ground the technical jargon real quick. Welding is a fabrication process that joins materials, usually metals, by using super high heat. You are literally melting the parts together, allowing them to cool, and that cooling process causes fusion. So you aren't just gluing 2 things together, right, or mechanically fastening them with bolts. You're actually fundamentally altering their molecular state so they become a single, unified piece of material. That permanent bond, well, that's the true art of fusion. Moving right along to Section 2, the 4 core welding methods. First up, we've got SMAW, which is commonly known as stick welding. This method uses an electric current to create a powerful, intense arc, which is exactly what generates those massive, iconic showers of sparks, right between a consumable stick and the base metal. And what makes this method so foundational is just how rugged it is. See, the stick is covered in this flux coating that actually burns off as you weld, and it creates a shielding gas that protects the molten metal from contaminants in the surrounding air. Because of that, you can stick weld outside, in the wind, or even on dirty metal. It's incredibly versatile for field repairs and heavy construction. Now notice that distinct blue hue of the arc right here? This is GTW, or TIG welding. Instead of a consumable stick that melts away, this process uses a non-consumable tungsten electrode. And since tungsten has the highest melting point of any pure metal, the electrode simply conducts the electricity to produce the weld puddle without actually melting itself. As a result, it is the absolute gold standard for high-quality, incredibly precise work, especially on tricky, thin materials like aerospace-grade aluminum or stainless steel. But fair warning, it requires a very steady hand, razor-sharp focus, and absolute control of the heat. So contrast that highly deliberate TIG method with GMAW, or MIG welding. This one uses a continuous solid wire feed that acts as both the electrode and the filler material, making it a super fast-paced, semi-automatic process. It completely removes the need to constantly stop and start just to replace a burned-down stick. You literally just pull the trigger and weld. Because of this point-and-shoot speed and efficiency, MIG is the absolute go-to for rapid factory production environments and automotive manufacturing. Finally, we wrap up the core methods with gas welding. By relying on the combustion of fuel gases combined with oxygen, you get this incredibly focused, intensely hot flame. What makes this setup so uniquely versatile is its dual utility. By just adjusting the gas mixture and the equipment attachments, professionals can use that precise flame to beautifully weld 2 pieces together, or they can crank up the oxygen to effortlessly cut straight through thick, solid metals. It's a real game changer. All right, let's jump into Section 3, the 5 essential joints. So the crucial point to understand here is the absolute simplicity of the butt joint. You're just taking 2 flat metal pieces and joining them directly at their edges, laying them flat on the exact same plane. It's really straightforward and incredibly common, especially in pipeline or sheet metal work. But it absolutely requires excellent, deep penetration of the filler metal to make sure the resulting single piece is structurally sound all the way across the seam. Building on that, we have the T-joint, and it forms exactly what it sounds like. One piece of metal sits directly perpendicular to the surface of the other piece, creating a solid T structure. You're going to see this joint utilized absolutely everywhere in structural framing, bridge building, and machinery bases, basically because of its ability to brilliantly bear vertical and intersecting loads.
Next up is the lap joint. If you need incredible strength and you've got the material to spare, you simply overlap the two pieces of metal before fusing them. The weld is then applied right to the top edge of one piece where it meets the surface of the other. Because the metals are literally stacked on top of one another, the resulting joint provides just exceptional thickness and resistance to shear forces.
Then we have the corner joint. By joining two pieces at their ends to form a clean 90-degree angle, this technique forms the fundamental corner structures of countless everyday objects. Whether it's fabricating a watertight metal box, constructing heavy machinery frames, or building the chassis of a trailer, the corner joint is absolutely essential for creating rigid, three-dimensional spaces. And we conclude this little geometrical breakdown with the edge joint. So unlike the butt joint, where pieces lay flat end to end, here the parallel edges are placed side by side and fused right across the top. It's a fantastic way to cap two plates that are sitting flush against each other, and it's often used to reinforce the edges of sheet metal parts so they don't warp under stress.
Moving on to Section 4, Professional Setup and Safety.
Look, welding is definitely not a craft you can just jump into wearing a t-shirt and jeans. The rigorous safety protocols, specifically personal protective equipment or PPE, are completely non-negotiable. First off, you absolutely need an auto-darkening helmet to protect your eyes from intense UV rays that can literally cause permanent flash burns. No joke. You also need heavy-duty leather gloves to ward off extreme radiant heat and flying sparks. Toss on a fire-resistant safety apron to protect your body. And of course, you need crucial clean ventilation to keep you from inhaling the toxic fumes generated during that high-temperature melt. Grounding all of this on a true professional's workbench, you can really see how it all comes together. Alongside the boots, gloves, and helmets, you need essential tools to execute high-quality work. Our source specifically points out top-tier equipment like the OTC Daihan XD350S welding machine, paired with crucial hand tools. You've got the chipping hammer for cleaning hardened slag off your welds, heavy wire brushes to prep the metal, and heavy-duty clamps to hold everything rigidly in place before you strike that first arc. And finally, Section 5, Real-World Applications. Comparing these two very different applications really shows the true versatility of the fusion arts. Over on the left, you've got highly technical automated assembly lines fabricating a custom off-road vehicle chassis that requires exact, clean, robotic precision to ensure the vehicle drives perfectly straight. But then, on the right, you have heavy-duty, high-pressure pipeline welding. This requires incredibly robust, flawless joints crafted by human hands that can withstand immense environmental pressure out in the brutal elements. It just goes to show how adaptable these core welding skills truly are across totally different industries. And just consider the sheer vertical scale of this work for a moment. Suspended high up in the air, these professionals are performing steel beam construction for high-rise buildings. It really highlights the immense bravery and absolute structural perfection required to construct the metal skeletons of our modern city skylines. I mean, think about it. Those massive beams, carrying thousands of tons of weight, are held together by the exact same principles of arcs, melting metal, and fusion that we just walked through together. Which brings us to the end of our explainer. I want you to literally look around you today. Whether it's the towering bridge you drive over, the frame of the chair you're sitting on, or the complex web of pipes delivering your water, what structural marvel in your life is held together by the art of fusion? Welding is everywhere once you know what to look for. Thank you so much for joining me on this deep dive. Keep observing, keep learning, and I'll catch you in the next explainer.